Hello, my name is Noah Abji, and today we're going to learn how to graph on all four quadrants of the coordinate plane. So let's begin. So when we're going to talk about how a coordinate plane works, you might already know what a coordinate plane is, but in case you don't, it's best to start from the basics. And the basic that I'm talking about is a number line. The number line in a coordinate plane are very closely related. So below I have an example of a number line. Now, you've probably worked with number lines in the past. They run from negative infinity to positive infinity. So this is why we have the arrows at the end here to show that this number line extends on forever from 0 all the way to infinity and from 0 all the way to negative infinity to the left. Now, the part of the number line that we can see goes from -3 to 4. Now, the reason that the number line is important is because it's very related to the coordinate plane. We can plot points on the number line, just like we can plot them on a coordinate plane. So let's go over this example first. Let's say I said plot the point 3 on the number line. Well, that would be fairly easy. I would put a point right at 3 right here. And if I said plot the point -1/2 on the number line, well, negative and then 1/2 over is about, or like roughly right there. So the number line is quite simple. It runs only left and right. And I can say plot this point, plot that point, and you just put it on the number that it goes on. But now we're going to look at what a coordinate plane looks like and understand how it's related to, but a little bit more complicated than the number line. So below is a coordinate plane, and it's a little bit small, so it may be difficult to see, but then it's basically two number lines, one that goes left and right, and one that goes up and down. So I'm actually going to draw the arrows because we don't have them on this number line. So what you'll see on this coordinate plane is that we have what we call axes. One that runs left and right, so goes from negative infinity over here, so negative infinity, all the way to positive infinity over here, to positive infinity. So this is where it's like our number line. If you just ignore all the stuff above and below it, it's just a left-right number line, like the example that we have above. Now, the other thing you'll notice is it's not one-dimensional. It has two dimensions. There's also a number line that runs up and down. Up here, we have positive infinity that the number line's going to, and we have negative infinity down here that the number line's going to. And together, those two number lines make what we call the four-quadrant coordinate plane. Now, the reason that we call it four quadrants is because it divides the coordinate plane into four different sections. Now, sometimes we look at individual sections. So we might only look at quadrant 1, where numbers are always positive. However, we could look at the other quadrants as well, where numbers might be negative and some might be positive, and that's why it's four quadrants. And some useful terminology to know is that the number lines that run left and right and up and down, we have names for them. We call them the horizontal and vertical axes. Now, horizontal means level with the horizon, essentially. And so level would be running left and right. And then vertical would be the other direction, which is up and down. So we call these the horizontal and vertical axes. And in order to better understand them, we can simplify it to calling it the x-axis and the y-axis. So instead of always having to say horizontal and vertical, we can use the letters x and y. So if I were talking about the y-axis, that means the one that runs up and down. If I was talking about the x-axis, that means the horizontal axes, or the number line that runs left and right. And you can actually see that on the graph here. There's a y here, which I just circled and gone the way of, and an x right here. So now let's take a little bit of a closer look at the number line while it's a little bit bigger to better understand how we use it. So I know there's a lot on the screen right now. We'll get to what all of this means in a second. The first important thing is that this middle point here, right in the center of the graph, we call this the origin. Now, the definition of the word origin basically means the beginning of something, where something comes from. The entire graph stems out of this point, which is why we call it the origin of the graph. So that's right at the center here. Now, this is where the number line differs a little bit from the coordinate plane. If I were to tell you to graph the point 3 on a number line, you would put a dot where 3 is. But if I were to tell you graph the point 3 on a coordinate plane, you wouldn't be able to, because there's a 3 here and there's a 3 here. So does that mean the point goes here, or does the point go here? Or maybe it's both of them, which would be all the way out here, or it's right in between them, which would be over here. And obviously this creates a sort of dilemma for where we put the point. So instead of just saying one number to describe where we're talking about on a coordinate plane, we need to use two numbers, one that represents how far left and right we are, and one that represents how far up and down we are, or our x position and our y position. Remember, x is the horizontal axis and y is the vertical axis. So the way that we write these are in what we call points. So all of these here are points. This is a point. We write it inside parentheses, just like this, and we have two numbers, one describing where we are in the number line left and right, so the x point, and where we are on the number line up and down, so the y point. And always the x goes first and the y goes second. So here's what this looks like with an actual example. So let's take this one. We pronounce this 3, 4. So we need to graph the point 3, 4. Well, the first number represents our x coordinate, how far left and right we are. So let's find where 3 is on the right-left number line. So 1, 2, 3. So 3 is right here. And I'm actually going to draw this in a different color to show that this is temporary. I'm just making a mark on the graph. It's not my point, it's just temporary so I can remember. The second coordinate is the y coordinate. The second one's always the up and down one. And that is 4. So we need to find where 4 is on this graph. So 4 is right here. So now we have two separate points, but this represents one point on the graph. So how do we turn these two values into one point? Well, here's how we can do it. Because the x direction is only left and right, and the y direction is only up and down, that means that my x value, how far left and right I am, can always be 3, even if I'm up here. If I put a point up here, my x value is 3. If I put a point down here, my x value is still 3. My x value doesn't change, which means no matter how far up or down I travel, since I'm not traveling left or right, that means that I'm also not traveling left or right on the x axes. So this is still equal to x as 3. The same thing occurs for the y axis, which is up and down. If I want to put a point where y is equal to 4, so right where my yellow dot is, I can travel as far left and right as I want. I could put a point right here. I could put a point over here. I could put a point way off the graph over here, as long as it's the same height, because it's 4 up above the origin, which means that my y value is 4. Traveling left and right doesn't affect how far up and down I am. So here's what I do then with these 2 points at y equals 4 and x equals 3. Basically, I take the points, go out 3, and then go straight up until I get to where 4 is, which would be right here. And this point here, this point is out 3 and up 4, which means that our x value is still 3 and our y value is still 4, which gives us the point 3, 4. So that's the easiest way to do these types of questions. And I know that was a long explanation, but it's important to grasp that no matter how far up or down you travel, your x value doesn't change. Remember, x is the horizontal left and right axes. And no matter how far left or right you travel, your y value doesn't change. Remember, y is the vertical axis, which is up and down. All right, so let's do the examples with 3 other points. So 2, 2. Remember, this is the x value. This is the y value. So x equals 2 is right here if we go at 2. And then y equals -2 is right here. So let's go out 2. I'll draw an arrow. out 2, and then down 2, and we get to this point right here. So this point is going to be 2, comma, negative 2. All right, this point here, negative 3, comma, negative 1. So we go negative 3 out because this is our x value, and we go negative 1 up, or we go 1 down because it's negative. So we go right here. So this is our y value. So we're negative 3, negative 1. So that's our point here. And then finally, 0, comma, 0. So this is the x and this is the y. Now there's no 0 labeled on this graph. However, we assume the origin, which remember is the center point, to be when x or y is equal to 0, which means that this point here, right at the center, is when both our x and our y value are equal to 0, which means that we're at the origin, and this is our point, 0, comma, 0. And it's even labeled up here. All right, so now let's do some review questions. So there are 2 review questions, one where you need to plot a point on a coordinate plane, or at least just kind of figure out where it would go given the screen. And the second is find the coordinates of point B, which is labeled right here on the screen. I'll give you a few seconds to pause the video if you'd like to try it before I explain the answer. All right, so the correct answers to these questions are plotting point A right here, and then finding the coordinates for point B as -6, comma, -7. All right, so first let's plot point A. So remember, our first one is the x value, which is how far left, right we are. And the second one is the y value, which is how far up and down we are. So how far left and right we are. So we're -6 on the x, which means 6 steps left. So if I count, and remember, this graph isn't labeled, so you have to count accurately. We go 1, 2, 3, 4, 5, 6. And I can draw that 1, 2, 3, 4, 5, 6 out to the left to get -6 right here. And then we go up 4. So 1, 2, 3, 4. So our y value is 4. Together, those 2 values meet to get point A right here at -6, comma, 4. Secondly, for point B, it's asking us to find the coordinates. So instead of actually plotting a point with coordinates, we need to find what those coordinates are. This is where it's important to remember the x value comes first. We do x, comma, y. So let's find where it is on the x-axis. So it just happens to be on the same x value as our point A, remember, because no matter how far up or down we travel, the x value doesn't change. It's right below the -6, which means that our x value, how far left it is -6. And then for our y value, if we count how far down it is, because remember, down is the negative direction, we get -1, -2, -3, -4, -5, -6, -7. So -7, and that is our y value, which means that the coordinates for point B would be -6, comma, -7. That's all for today's video, and thank you for watching.